All right, here we have our tanks. If we look at the A state right here, we will see that as water comes in to tank 5, it'll fill. Remember, water seeks the lowest point, so the water will stay down here at the bottom of tank 5 until it reaches this point in the tube going from 5 into 2. At that point, we switch to B state, which is right here. As this water rises up into this tube, gravity pulls it down into tank 2, so it falls down. And here, the bottom of tank 2 starts to fill up. Again, water seeks the lowest point. It will stay here at the lowest point until it starts to approach this tube over here that leads eventually into tank 4. Now we find ourselves in the C state, where water is moving from tank 2 into the small tube over at tank 4. Again, water seeks the same level, so the water in tank 2 and the water in this intermediate tube will rise at the same rate. Water will fill up in that way. And so we see D state, where the water has filled up to this point, and the water in tank 2 and the water in the tube leading to tank 4 are at the same level as each other. They are equal. This water over here is still higher than either of those, so it continues to freely flow through this transition tube into tank 2. Now we find ourselves in E state, where the water in tank 5 is still higher than the water in the other tanks, so it continues to flow in. The water in tank 2 and the water in this tube are still at an equal level to each other. And so this water and this water, that's how this water kind of pushes into here, because the gravity in tank 2 and the gravity in tank 4, or this tube, are the same. Water seeks the lowest point, and this is the lowest point. If the water in 2 was higher, it would push down, the water would go down in 2, and it would go up in this tube until they reached an equilibrium, until they equalized, equalizing the pressure. I should note that this is all assuming the same air pressure in tanks 2 and 4. Probably they're just open tanks in the same room. You can get different outcomes if you have different air pressures, like in different rooms or something, but that is crazy complicated. We are assuming a spherical sewage system here. So here, F state, we have this situation where the water from 5 keeps flowing in because its level is slightly higher. Tank 2 fills up to this point, and the water reaches this point at the top of the tube leading into tank 4. And so tank 4, this tube, and tank 2 are all at an equal level to each other because water seeks the lowest point. You see, as the water goes up here, as the water rises in tank 2 and this tube, water rises, and then over here, so for a period of time, the water starts falling into tank 4, and tank 4's level rises slowly until they are equal, at which point tanks 4 and 2, their water starts rising at the same time. And if tank 4 and tank 2 have the same bottom and same top, they will fill at the exact same time. Now previously, all of that was assuming that tanks 4 and 2 were on the same level and the same size. If we take our G state here and assume that tank F and tank L, or tank 4 and tank 2, are on 2 different levels. You see tank 2 has a lower bottom there. The fill equilibrium point between tank 2 and this transition tube still occurs at the same rate. So water comes in from tank 5, pours into tank 2. It goes up, up, up until it meets the bottom of this tube. Then the water in the tube and in tank 2 continues to advance slowly, inexorably, until this water reaches this horizontal tube's point, at which point it begins pouring into tank 4. Tank 4 slowly fills until the water reaches the bottom of this tube. Then all 3 will continue filling up until we reach the point we find ourselves in this drawing, where 4 has this level and 2 has this level. And they are at the same level. This also happens to be the top of tank 4, and that is why tank 4, or tank F, will fill first.